In this video, we're going to be looking at the application of the probability density function. So applying the theory that we've looked in previous videos and doing it to an actual question that you'll more likely see, in using the different parts of the theories, combining them, and being able to solve a question. So here's the question. So an electronics store models how long in days it takes for their TVs to be delivered. They find it is modeled by the probability density function here. Okay, so we're finding that the number of days it takes to deliver is modeled by this, so that's a probability. So it depends, like obviously it's going to vary how many days the TV is going to be delivered, and so it varies depending on this function. So when you read this question, there's a few things you really want to pick up on. So in days, so it's quite important that in days that they said this, and that's because if it says in days, and that means you have to answer in days as well. That means also the domain of x, these numbers here, are in days. But the most important thing is you also have to answer in days. So you can't just say that whatever the question is, let's say the expected number is equal to 7, then you can't just say 7, you have to say 7 days, for example. So it's modeled by this. So we say it's a hybrid function with a 0 elsewhere. It's the typical 0 elsewhere, and that means that we don't have to worry about anything that's outside of this domain 1 to 9. And then x to 40, so we can graph that. Yeah, but that's obviously not an actual question. So the first part of the question, so just take note of this function. So it's x on 40 between 1 to 9. So the maximum delivery time. So the maximum delivery time and the minimum delivery time. So now we know that it's 0 elsewhere, anywhere else. So because it's 0, that means the probability of it being delivered in 10 days, 11 days, 12 days is 0. So it never happens. The probability that it delivers in 0 days is also 0. Now, the domain was 1 to x to 9 of x to 40. And no matter how unlikely it is that whatever the domains are, it can still occur between 1 to 9. So we know that the maximum delivery time, so this is fx, if you remember. So fx, so the maximum delivery time is going to be this number here, 9. So therefore, the max delivery time is 9 days. And remember the days. And then you also have to write for the next part the minimum, and that's going to be 1. So therefore the minimum delivery time is 1 day. You need to make sure for these questions you don't try and think, oh well, the minimum delivery time is going to be 0. You always have to look at the question. You can't just think sort of logically. You rather have to look at the probability density function given. So the next part. So what is the probability that it takes less than 5 days for it to be delivered? So that means it can be 5, 4, 3, 2, 1, or 0. But if you remember, the 0 is the probability of it being delivered in 0 days is also 0 because there's 0 elsewhere. So we have x on 40, 0 between x, between 9. So we can find that less than 5 days. First thing is a less than 5 days. So it does not include 5. Yeah? But it takes less than 5. But because this is a continuous thing, so with discrete, you would then have to find the probability of x is less than or equal to 4, for example, or the probability of x. So less than or equal to 4. So you could do that for discrete, but you can't do that for continuous because you don't just go from 4 to 5. It's not just 3, 4, 5, 6. Like these are discrete. You can't. That's not it. Rather, with continuous, have it 3, 3.1, 3.15, 3.9, 4, etc. Like obviously there's more than that, but I'm just trying to show you can't to say because it doesn't include 5, you then have to start at 4, because there's going to be numbers between 4 and 5, such as 4.645 days, for example. So what you can think about this, if it does not include 5, you have to find the probability of x being less than 5. But we also remember that with continuous, this is just equal to probability of x, because these are equal. So how do we find the probability that it takes less than 5 days? Well, the probability it takes less than 5 days is going to be the antidiff, so the area between 5 and the lowest domain, which is 1. Then x on 40 dx. So you antidiff that and you get x squared on 80, because you bring the 2 down, 2 on 80 gives you 40, 5, 1. So that is equal to 25 on 80 minus 1 on 80. So it equals 24 on 80, which simplifies down to 12 on 40, which is 6 on 20, which is 3 on 10. So then we'll just get rid of this so we can have some room. And then we have to write a worded answer. You can't just write that. Because it's a worded question, it's always good to write a worded answer. You can say that the probability, so you repeat the question, so the probability that it takes less than 5 days is 3 on 10, or so that's an exact, or you could have said 30%. And obviously if it's at decimals, then you write 0.3000 to however many decimal places they want. But typically for this question, because it's a nice number, they would have probably said just left it, so you would have had to leave it as an exact answer. So that's 3 on 10. So probability that TV is delivered in less than 5 days is 3 on 10. Yeah, so now the next question is it takes between 5 to 8 days. Now I skipped B, but that's because got the order mixed up. So it's just A, C, D. They're just separate sort of questions. They're interrelated. So it takes between 5 to 8 days. So how do we do this? We know that we have to find that the probability of x is between 5 and 8. So what does that equal? Well, that is equal to x is less than 8, but x is greater than 5. And then we could minus that from the probability of x being less than 5. So if you can just draw this, and you can imagine here you have sort of 9, and then down here you have 1. And obviously we're not drawing the actual graph, but just so we can visualize what we're doing here. Now we want to find between 8 and 5. So what we can do is we can find the probability of x is less than 8. So that's the probability of x is x than 8. So that's all that area here. And then we know that we can work out what the probability of x is less than 5. So that's all this area here. And as you can see, obviously this is a pretty simplified diagram, but if you have x is less than 8, because here is 8, and you get the probability of that, which is all this area, minus from the probability of x is less than 5, then we get this area in between here, which will be the probability of between x to 5 and 8. Now we already know this from the previous question, the probability of x is less than 5, and that was 3 on 10. So we just need to calculate the probability of x is less than 8. So the probability of x being less than 8 is going to be equal to 8, 1, so that's the lowest domain, x on 40 dx. And that gives us x squared on 80, 8, 1, which equals 63 on 80, because 8 squared is 64, minus 1 gives us 63 on 80. Then we have to minus it for 3 on 10, so we'll convert 3 on 10 back into 80, so just times the top and bottom by 80, and we get 24 on 80. So therefore the probability of 5x8 is equal to 63 on 80 minus 24 on 80, which equals 39 on 80. So then you'd have to write as the question again. So you'd say that the probability that a TV is delivered between 5 to 8 days is equal to 39 on 80. And just like before, it doesn't matter if you're talking about this being inclusive or exclusive. And so now going back to part B. So the expected number of days for the TV to be delivered. So we have to work this out. So first thing is the expected number. So the expected number is just equal to the mean. So then we think for the mean for the continuous, what's the formula? Well, the formula is AB x times fx dx, and that is equal to e to the x. So we just sub this formula in and we can get the mean. So what we can go that the expected number is equal to up here, which is the top, which was 9, 1, x times x on 40 dx. And this is equal to, that becomes x squared, so then this is x cubed. Bring the 3 down, so then you have 120, because 3 on 120 is 1 on 40. 9, 1. And then you sub those values in, so you get 91 on 15. And you wouldn't normally have to do that calculation by hand. So then we'll assume they say to 2 decimal places. So this is approximately equal to 6.06667. So then it's to two decimal places, you can go it's to 6.07. So therefore you have to write, as I said, a worded answer. So the expected number of days for your TV to be delivered is 6.07 days. And once again, remember the days.